Question number 3, Part A. Chemical reactions occur as a result of corrosion of particles. Give a reason why not all corrosions are effective. So the reason is some of the particles may not possess sufficient energy for proper corrosions, or some particles may not be colliding in the right geometry. So you can say some particles do not possess sufficient energy or may be colliding in the wrong geometry. So that's how you answer that, and you get 1 mark. Part B, state and explain how the following factors affect the rate of reaction. The first one is surface area of reactant. So surface area increases increases the rate of reaction, and the vice versa. This is due to increase in area of contact of reagent or number of corrosions. So you can say increase in surface area increases the rate of the reaction. The rate of reaction, or vice versa. This is due, so we can say this is due to increase in the area of contact or you can say number of collision. Okay, but number 2, pressure. So increase in pressure for gaseous reagent increases the rate of reaction. So we say increase in pressure increases. That is, before we do that, pressure for gaseous reagent increases the rate of reaction. The rate of reaction. The rate of reaction or vice versa. That is, decrease in pressure decreases the rate of reaction. So we say high pressure brings the reacting particles together that is reduced volume reduce volume. Increase in pressure will reduce volume, hence more corrosion. Hence more corrosion. So that's how you answer that. Let's go to the next part of this question. Part C, we are told in an experiment to determine the rate of reaction, marble chips were added to excess 2 moles of hydrochloric acid. The equation for the reaction is we have the marble chips, which has calcium carbonate, plus hydrochloric acid, which will form calcium chloride. In aqueous form, we have carbon dioxide or carbon 4 oxide, which is a gas, and we have water, which is liquid. The volume of carbon dioxide or carbon 4 oxide produced was measured at 25 degrees centigrade and recorded after every 30 seconds. The table 3 shows the result obtained. So we have time in seconds. The volume was recorded at intervals of 30 seconds as shown on the table given here, table 3. Roman number 1, on the grid provided, plot a graph of volume of carbon 4 oxide, that is on the vertical axis, against time, the horizontal axis. So we go to the grid that was provided. So this is the grid. I have already put the table that you are going to use. So you plan your scale. Since we are told that the volume is on the vertical axis or the y-axis, it is from 0 to 133. So it means if you put 20 here, 40, that is 60, 80, 100, 120, 140. So that scale will be able to work. So we have 20 from 0, we have 40, we have 60, we have 80, we have 100, we have 120, and this is 140. The highest value is 133, so that will be able to accommodate that. So this is a volume of that is volume, and you can say this is CO2, volume of CO2. So this is time. Time is from 0 to 240. So let's use a different scale: 30, 60, 90, 120. So that will be able to fit. So we can say this is 30, this is 60, this is 80, not 80 but 90. That's, we have 120, 150, 180, we have 210, we have 240. So that's the maximum value, that is 240. And this is time in seconds. So to be able to draw that, you need to now again to use the values that are provided. So when time is 0, it means we are given volume is 0. So we can use you can use a dot or a cross. I'm going to use a dot. When time is 30 seconds, volume is 62. So you can say when 30, 62. We have 10 small squares here, so we get our 62 there. When it is 60, we have 92. This is so we have here we have 1, 2, 3, 4, 5. So we have let's correct that. We have one small square representing 2 because they are 20. So we have 60, we have 92. So this is 80 up to the middle one, 1, 2, 3, 4, 5. That is 90. So 92 is there. we have 90, we have 113, this is 120, 100, so 110 here, so 112, 113 should be there. Then we have, when it is 120, we have 124, so 124 is there. We have 150, we have 130, so 130 is in between 140 and 120. Then we have 180, we have 132, 132 is there. We have 210, 133, 133 should be there. Then we have 240, we have the same value. So those are the points that we are going to use to plot our graph. So you are going to use your free hand to draw this curve. Do not use a ruler. So let's do that. So this is a graph that you come up with, or I have come up with. You try to make it as smooth as possible. So once you do that, you get 3 marks. You get marks for the scale, the correct scale. You get marks for the curve and the plotting itself. So Roman number 2, using the curve, determine the rate of reaction at 45 seconds. You get 1 mark, and at 105 seconds. So the rate of that is the rate of reaction at 45. That is 45. The second is this is 30. This is 60. So 45 is in between 30 and 60. So you're going to draw a tangent at 45, and once you draw the tangent, you calculate the gradient. You do the same to the 105. So using a ruler, you draw the tangents. Let's go ahead and do that. So these are the tangents. This is the first tangent where you draw at 45. 45 is in between 30 and 60. So you get it's around that should be 78 on the y on the that is the volume. So you draw that tangent using a ruler. The other one, you drew a tangent at 105. So this is a tangent. So for you to get the rate of reaction, you get the gradient of this tangent. These are tangent. So you can say you can call it R. It is equals to. Now I choose 2 points. You take 2 coordinates. I'll start with this one here. So I have before we do that, we need the coordinates. So I got the coordinate. This is x. That is time is 0 and 30, and the other one I took this one, which is around. We have down here we have this is 105. So we have 105, and the other one is 105 and 140. So those are the 2 coordinates on the first gradient at 45. So you can say rate of change is a gradient, and the gradient, this is 140. It will be 140 minus 30 divided by 105 minus 0, and that should give you, when you use your calculator, you get 1.047. So that is the value, that is the rate of change, or that is the rate of reaction at the 45 seconds. The other tangent, you can take 2 points. The first one I took 0 and 0, that is the first one. The other one I took this is one is 9 and 80. This point here, I took another point here, which is if you take here this point, it's a 153 along on the x-axis. That is 153, and the y-axis is 140. So the same case, you do that. The rate is equals to, you get the gradient, it is 140 minus 80. You divide by 153 minus 9, and you'll be able to get that will give you 60 divided by 146, which is approximately 0.4, that is 0.411. So that is how you work it out. The figures may not be close, but if you do it manually, maybe you can get a more accurate value. But that's a procedure to go about this this question. So let's go to the next part. Part 3, give a reason for the difference in the two rates. So from our calculation, the previous part, that is, you can see that the rate of reaction is higher at 45 seconds than at 105 seconds, because this is 1.047 and this is 0.411. So the reason is that is the rate of the reactants are low at 105. So you can answer this like this. So you say rate, that is rate at 45 seconds is higher than at 105 seconds. This is because the reactants have reduced. Reduced at 105 seconds. So that's how you answer that, and you get 1 mark. Part 4, using the graph, determine the mass of marble chip that reacted. So we are given the formula, the mass of calcium is 40, carbon is 12, and oxygen is 16. So with that, molar gas volume at room temperature, pressure, and pressure is 24,000 centimeter cube. So this is how, if you look at our graph or from the table, you can see that 133 centimeter cube of carbon 4 oxide or carbon dioxide is 133. So to be able to calculate, you say volume of carbon dioxide is equals to 133. So you can calculate the moles of carbon 4 oxide is equals to the volume, which is 133, divided by the molar gas volume, which is 24,000. That will give you 0.00554. So once you get that, you note that the moles of carbon dioxide is equals to moles of calcium carbonate. That is calcium carbonate. That is the ratio is 1:1. Ratio is 1:1 from the formula given. So we can say relative formula mass of carbon, that is calcium carbonate. This is calcium carbonate is equals to you add calcium is 40, you add carbon is 12, and you add to 16 times 3, that is for oxygen, and that should give you 100. This is 48 plus 12, that is 60, you get 100. Therefore, you can be able to get the calcium carbonate that reacted. So calcium carbonate is equals to, since the ratio is 1:1, it is 0.554. You multiply by 100, and that should give you 0.554 grams. So that is the amount or the mass of marble chip or the calcium carbonate that reacted. And if you do that, you'll be able to get 2 marks.